Hello, Asalat from Mumbai, India. Welcome to my talk Offensive Embedded Exploitation, getting your hands dirty with IoT and embedded exploitation. So, let's have an introduction for this. Let's have a So the agenda for this talk is first we'll have an introduction, then we will set up an arsenal, then we will have a recognition session, then we will have a showtime, that is firmware analysis, then dynamic testing, and finally we will touch base the fuzzing, reverse engineering, and exploit development section. Okay, so let's get started with the introduction. Myself, Kaustubh Padwad, also known as Security Beast on Twitter. I'm author of 2 dozens of exploits, and I'm a product security researcher, and I like to share my knowledge. So let's have an introduction with the IoT. So I have classified IoT in three areas. First is industry IoT. Second is human or wearable IoT, and third is world IoT for rest of everything. So IoT is used in multiple industries. For example, here we can see a snippet where it says we are using IoT for smart manufacturing, smart government, mobility, buildings, health, and agricultural sector, smart buildings, and power grid and transport. So smart manufacturing industries are using IoT to improve their product quality, improve the quality time for the, improve the manufacturing time of the product, and maintain on storage purpose. So let's take an example. Like there is a company who produced the ice cream. They want to ensure that their ice cream is not getting waste or not getting melt in a warehouse. So those ice creams are stored in a cooler. So that cooler connects with one small sensor, IoT sensor, which can monitor the temperature of the cooler, which can monitor the uh, power supply to the cooler, which can monitor the multiple things, means multiple parameter it can monitor, and it will send the real time alert. So generally these warehouses are pretty much big, so like thousands of warehouses are there where this everything gets stored. So to keep track on each and every fridge, for example, in one warehouse there is a hundreds of fridge. So to keep track of each cooler, it is not possible for everyone that keep rounding keep rounding there and check that whether fridge is working, whether temperature is not. So to avoid this, what we can do, we can put one small sensor inside that on that cooler. That sensor will keep checking everything, like its power supply, its temperature, and it if anything goes wrong, it will send an alert to the store manager. So that store manager or that warehouse manager will come to know that, oh, fridge number X is not working, it is having temperature issue because of power cut. So he can quickly send someone and get those things done, which can save lots of ice cream getting melt. Okay, just for example, so this is how manufacturing industries are using IoT devices for multiple purpose. Then a government. So we can see that there are roads. We have a street light in city. Street lights are continuously on. So if we put one small sensor which keeps eye, or if someone is passing, then only it will turn on the light. So it can save a lots of electricity bill for government, and it will also save electricity energy. So go green kind of stuff, and it will turn on the light only when it is required. Then mobility is the key base for IoT, because there are few bands like NB IoT, narrowband IoT band, which provides the connectivity to the IoT dongles using mobility. Smart digital citizen, that is us. We are getting smart every day, smart watch and everything. Like we have a smart watch, smart glass, and many smart products are coming at our home. Then open data, okay, it's data stuff. Then health is the key element for IoT. Like I heard about a smart ambulance. So the moment i- patient enters inside the ambulance, what happens is like doctor that those IoT sensors will get connected to his body, and the moment sensor get connected to his body, the real time data of his body will send to the doctor, so that patient don't have to wait to reach a hospital and get tested. So doctor can start treating patient dynamically on the go inside the ambulance only. So agriculture is one of the good example. Like in some rural area, we have seen there is a heavy power outage called load shedding. So if sometimes power come at midnight 3, then farmer have to go to the farm and he have to turn on that motor to send the water to this farm. So what this IoT devices will do, it will sense that electricity is gone. It will turn off everything. Once the electricity is back, it will automatically turns on the motor and give water to the farm. And also it can sense something like is the water is required for soil. So it can sense the dryness of soil. If the soil is dry, then it can automatically turns on. So many such test cases are there in farming also, which is in use for IoT purpose. And smart building, I have excellent example in next slide. And smart transport, Tesla is an excellent example. Okay, now in human IoT. So these devices are so much improved that it enter inside our body. Like in the pacemaker, you can see here, the came. Pacemaker is responsible for maintaining your heartbeat. So it resides inside your body. Similarly, if you have a child diabetic patient who cannot take care by herself, so you can install this IoT insulin pumps also. So this pump will trigger when you fire a command from device, or it can be automated. So like a 10 ml shot to your baby, when it is required, it will automatic on certain time it will automatically uh, give a insulin. And you can see the cow here. So IoT for others is like a smart, you can call her a smart cow. So IoT for others is like people are developing multiple gadgets. Like one, I have seen that one belt is getting developed for animals. So it will analyze their behavioral pattern and body temperature, and if there is something that needs to be taken care, it will create a alert and send to the owner. You can track your pet with this belt. Also you can monitor its temperature. And this device itself will monitor their pattern, means their behavioral pattern, and generates a real-time analytics. So if your pet needs to take to the doctor, it will automatically tell you. So you can see that IoT is covering everything. Here is an example of smart building. Those who have over headphone, just low down the volume. So definitely would like to have a look at. Definitely would like to check in this Fly Zoo hotel. Okay, so with great power, great responsibilities do come. Let's have a take at some critical IoT news. So here you can see a medical pump and pacemaker threat as a doctor simulated hacked overdose. You heard about a witchcraft? Our grandparents used to tell that with witchcraft, the will kill people if uh, some black magic is done, which used to kill the people. So I don't know about that. I can't trust that. But here in IoT, definitely it is possible. Here you can see a medicine pump and pacemaker threatened as a doctor simulated hacked overdose. So your heartbeat rate, whatever currently it is, if I can control that pacemaker, and if I say that your heart should beat at a 500 beats per second, who can save you? No one, right? It will hardly take a minute to kill someone if the device is not secure. So you buy a product to surveillance your home, and it becomes a spy gadget for the hackers. So here you can see hackers break into smart home, play inappropriate music, and communicate with the resident via camera. Isn't it a strange? Also, it's scary for the old people. Mirai kind of botnets identified again. That is like a Mirai 2. I always feel someone is listening to me. Yeah. So exactly, you buy a surveillance product, and uh, it becomes a spy object for the hackers. No comments. And FDA recalls nearly half million pacemakers over hacking fears. The exactly same case study which I explained. If someone can control your heartbeat, then nothing left in the world to live. Okay, so my test case for this talk is how can this decent looking IP phone changes into a botnet. You might be wondering what I'm saying now. And why IP phone? Every large corporate have at least 30 to 40,000 IP phones, like 40 to sometimes it is 50,000 IP phones. Now, let's take 50,000 into, if you are able to compromise one IP phone remotely, that means you can compromise those all 50,000 IP phones. Isn't it a critical? Right. So you can build a 50,000 bots army with just one sophisticated exploit. Isn't it a critical? Definitely it is. So now let's think about a city having a group of like a city like a Mumbai having large corporate hub. We have many companies here, and most of them are BPO, KPO also. So how many IP phones think one KPO have? A big KPO I'm talking about, 7, 8, or 10 story building KPO. They might be having 50,000 to 1 lakh IP phones. So if you compromise 5 KPOs, means you have 5 lakh IP phones. So you have a 5 lakhs bots. Isn't it a critical issue? And if you compromise, if you target a group of organizations, like group of KPOs, then how many KPOs it could be? 10 KPOs per city. And if you target a country having KPOs, how many it would be? Millions and billions KPOs, right? So millions and billions IP phones with hundreds of KPOs. And if those millions of bots will fire a DOS attack, denial of service attack, distributed denial of service attack, you think anyone can survive? A product company like a Google, Facebook, Amazon, Flipkart, no one can save them, right? No one can save. Literally, no one can save them with a millions of attack, like millions of bots is attacking one web server. It could be a biggest denial of service attack in the history, right? So let's see how can we do it, or can we do it or not. Okay. So before we get started with the setup, what we have to do, we have to set up a arsenal. And many times wherever I present this talk, so people used to say, "Sir, I want to get started with IoT, but I don't have those fancy devices, or I don't have a testing equipment to get started with." So let's have a look what we need and how much we need to getting started with a testing. So here I categorize to this preparing the arsenal in two sections. One is basic setup, and second is advanced setup. So let's see why what uh, we need a basic means what is the minimum need of setup for this for IoT testing. The first thing we need is the Linux. Why Linux? Because Linux provide the lowest level access to the operating system. Second, vast community support is available. Third, seamless integration with QEMU. So what is QEMU? QEMU is a virtualization virtualization toolset. Means virtualization toolset or virtualization framework we can call it. So QEMU enables a virtualization for ARM, MIPS, MIPS EB, ARM, all versions, and MIPS big ADM. Means all kind of softwares you can emulate on the QEMU. Also, it provides a socket level access and lowest level access to the operating system. So if you connect any random device to USB or to any port, it will at least identify vendor ID, manufacturer, and what kind of device it is. Okay. So vast community support is available for all kind of drivers. Uh, we need a Linux for testing. You can see you're not an electronic guy. Why JTAG is here? We need a JTAG because JTAG is a de facto standard for testing the product. So let's say your company manufactures hundreds and millions of mobile phones. How you think they are verifying each and every functionality of device? You think that one guy is sitting there and checking whether contacts is working or all hardware PCBs is working? No, right? So there is a JTAG interface. Once you connect that JTAG to the JTAG interface of the device, it will perform a quick check whether everything is working or not. So, but why we need a JTAG? Because some devices don't have any way to access the device. Like they don't have a LAN port, they don't have a WAN port, they don't have Wi-Fi, they don't have Bluetooth, they don't have UART, they don't have SPI, they don't have GPIO. Then what we do? We need to connect to the JTAG to get hold of the firmware. Sometimes you may not found the pins there, but points are definitely present because JTAG is a de facto standard. Then when it comes to the IoT, it comes to the wireless. We want a wireless sensors, wireless environment with least wire we want to live. So to test such kind of protocols like Zigbee, Z-Wave, we need something to test wireless. So API Mote is that device which will test. It is from Riverloop Security. It will test all your wireless communication and wireless attacks like what we say, packet injection attack, packet replay attack, packet capture attack, all these attacks. Now connectors. Yes, definitely you need a connectors because connectors are live. So what you need in it, we need at least one LAN card, one extra WAN card, one Uber tooth, this screwdriver set, this Shikra. So Shikra is something which allow you to connect a JTAG, UART, SPIO, GPIO, and everything. So it is all in one connector. Whenever you order for two. And for hacking radio frequency, we need a hack RF from Great Scott. Okay. So all you need is this for getting started into embedded device on IoT device security test. Now, advanced setup. So there is no limit for advanced setup. You can go as long as possible. You can take, you can buy as many as connector you want, many jumper cables and everything, whatever you want, you can have it. There is no limit. The new type of device will come, you need a new type of connector. And one day your setup will become like this. I got it from DEF1 slide. Okay, so now we got tools. Now we need some weapons. We got a hardware, we got arsenal. Now we need a weapon. So, what weapons what tools we need? Software tools. We need a binwalk. It's a master tool for extracting all kind of file systems. Developed by Craig Hefner, DevTTYS, and amazing file system extraction tool. Then we need a Firmadine. Firmadine sets up QEMU. Firmadine sets up your emulation. Firmadine have multiple binaries, and Firmadine is a great tool for emulating the binaries. We need a burp suit. Almost everyone is familiar with it. Those who are not, it's a proxy tool. We can set up an interception with it. Then we need a Python, of course, to automate many stuff in this device testing. We need a Python. And lastly, IDA Pro. So IDA Pro is the best software, and IDA Pro is a must-have tool for embedded device security testing to identify critical vulnerabilities like shell command injection, privilege escalation, and to find the hidden backdoor, to find the hidden undocumented function. Everything can be done with the IDA Pro. Reverse engineering is the key concept for device security test. Now, once we have all this, we have to move towards our next section. That is most important section of security field, that is recognition. So first thing what you have to do is you have to know your device. I still remember the day when I got this IP phone for testing. I was assuming what I have to do with this. Like it's a plain IP phone. I can connect to IP base and make a call to everyone. But no, it itself a very big and very deep field. So first thing is we have to identify what kind of architecture it has. Is it a ARM device? Is it a MIPS device? Once we got the architecture for processor, then we have to identify what is the operating system it is running. Yeah, this also have operating system. So like we have to ensure whether it's a Linux, whether it's an Android, or it's a hard coded MCU code works on MCU programming, or what. Means first we have to identify that. Once you identify this architecture, then your operating system, then we have to identify uh, chipset specification. So does this device support Wi-Fi? Does this device support LAN card? Does device have serial console? Does device have UART console, JTAG console, GPIO console, or SPI console? Whatever it have. So first thing is to know your device. Here we can see it's RJ11 port, it's RJ45 connector. So definitely we can connect with a LAN port to this device. And before you start the device testing with hardware, first thing is you should ask for, you should be like this. I want more. Everything you should be asked. I want more. I want more. I want more. So what should ask? What should you ask? You ask for a product specification document, which something looks like this. This is a snippet format. So here you can see that device supports SIP2 V2 protocol. Device supports RTP protocol. Oh, that means it does not support SIP TLS and SRTP. So if your boss is using this kind of phone, then if you sit in between this phone, you can decode the communication and listen what your boss was talking to his boss regarding your appraisal, right? So you can basically perform a MITM attack and you can listen to their communication. So from this protocol itself, we come to know that this product is vulnerable, right? So many vulnerabilities you can identify from this. Also, you will come to know what is the device capabilities. Then you should ask for the device manual. So like here in device manual, we can see that the firmware of device is upgradable. It have a web management interface. It have a password management. It have a multi-user support. So if someone set up the password for admin user, then here you can see it's a multi-user support device. Then you should give a try to user or support kind of account. Then algorithms. So why you need a algorithm? Why you need to review algorithm? Because these algorithms are used to generate many things like a password to access the device, your Wi-Fi password to access the Wi-Fi, and many things. So let's say you have hardened the device and it's a completely secure and no one can hack it. And let's say if it is a running a algorithm for generating Wi-Fi password that MD5 some of your MAC address, isn't it super weak? The password will still look strong, but the algorithm is super weak. So all you need to do is the capture the beacon, run MD5 sum on it, and you will get the password to connect to the SSID. And generally, default passwords are everywhere. I still believe it's the biggest vulnerability. And a magic number. So what is a magic number? So magic number are those number which enable special diagnostic mode, special debug mode, and special developer modes on the device. So like in Android, if you go to your build screen, if you check your build number, you type 10 times there, it will enable the developer mode for your phone, right? Similarly, to access special diagnostic interfaces, developer interfaces, debug interfaces, there are magic number. If you want to enter in that mode, you have to enter that secret code. So you have to verify the magic number generation algorithms too, and also you have to verify that what is the impact if this magic number algorithm got leaked, and what you can do with the magic number. Some device provides a Linux level access, root level access with the magic number, and of course a user manual. Here what it say: default PC port connection type bridge, default username is admin, default user mode name user is user, web UI password is null. Wow, they created a web UI, they created a web UI management interface, and they created uh, multiple users, but they were least bothered about setting a security. And the web login port is 8080. So now you come to know that from this IP phone, we can connect to the web interface of it and we can log in with either admin user or a user mode. Okay, with a blank password. Get that noted. Okay, now whenever you perform a full, now once you set up a device, what you have to do, whenever you perform a port scan, first thing is like to create a port scan, right? Run a port scan on any connected device. That is our first thing. So whenever you run a port scan, you should always run a port scan with a full ports on embedded device at least, because you may see some this kind of strange ports 41565, 23255, 4046. These two ports were completely random, so it's not that this device have definitely 41565 is open. So it is something 41500 to 600 port it used to pick, that service randomly was picking, and 1380 and 4046. So I found a remote denial of service attack here, local denial of service attack here, and remote code execution vulnerability on port 1380. So you should always perform a full port scan. Now, before we move to the dynamic testing and fuzzing reverse engineering, I decided to first we touch to the firmware. So firmware will give you a wide picture of device, that what are inside the device, and you will have pretty much of now we are ready with our arsenal. Then we got as much as possible information from device. Now we have a device firmware, and we will get rest of the information from device firmware. Then we will attack that device on real time, and finally the last section, fuzzing reverse engineering, means after owning the device, what we have to do. Okay, so showtime. So this is something a firmware analysis we are going to cover. So the agenda for this is what is the firmware, obtaining the firmware, unpacking the firmware, and what kind of vulnerabilities you should look. So what is a firmware? A firmware is nothing but a file which contains the file system for the device, rootfs, its kernel, and bootloader. A file which may contain all this content, or the rootfs or the delta of the files, is called a firmware. So firmwares are generally two types. One is a full firmware, which is having a bootloader, which is having a kernel, which is having a root file system. Sometimes full firmware only have the root file system also. And second is a delta file. So delta file is the difference between your existing firmware and the new firmware. So those difference generally sent over the FOTA, and then it verifies the authenticity of the FOTA and it install on the device. Okay, so now ways to obtain the firmware. So here you can see some people allow on their website itself. So here you can see the IP phone firmware was available on their website. You can click on download and you can download the firmware. Second, obtaining firm update. So basically, whenever you see the new file system is available, set up an intersection for device. I have a proxy server at home, so whatever the updates I receive on device, it generally stores on my device, on my proxy server. So before clicking check for update or before downloading update, set up an intersection, then click on download update. So you can download the complete firmware from it. Third is extracting a device, like using a UART or using a JTAG, using SPI dump, you can get that firmware from the device. Then Google Docs like index off or FTP off is the one of the good way. Like generally we find with a Google Docs. And lastly, analyzing device traffic. So one fine day you switched off your you locked your phone, kept it, and you sleep. And next day morning, phone is saying your phone is restarted. How many of you found this? Almost everyone, right? So why this phone got restarted suddenly? As your phone was charged completely, so it should not restart. So what these guys do? They push generally a silent firmware update. So whenever you are sleeping, generally at 2 a.m., it generally sends a FOTA, it install and it reboots the device. So you have to keep track on, you have to keep eye on the device, that whether it is automatically updating, it is downloading the firmware without user consent. It happens generally. For critical fixes, for critical vulnerability fix, they generally push overnight update. Okay. So analyzing device traffic is one way to obtain the firmware. Okay. Now you got a firmware. Now what? just run binwalk -e and extract the firmware? No, that is the dumbest one. I ran once binwalk -e on one encrypted firmware and it generated too many LZMA file and uh, pull my uh, which pull my complete system. Okay, so first thing you should do is a entropy analysis of device. First, you should know whether the firmware is encrypted or compressed. If the firmware is compressed, then definitely you can extract it with the appropriate reader. If the firmware is encrypted, you can't do it. You can't do anything without supplying the proper organ. Okay, so here is an example of entropy analysis. Looks like this is complete straight one line. That means this is a completely encrypted firmware. You cannot decrypt it without a proper password. So here you can see some portion here, here, and here is down. So that means this portion is unencrypted. So what you can do, you can extract those offsets using DD and read the content inside of it. Second, you can perform a hex dump and see what contents are there. And third, you can perform a signature analysis. So it will give you at least the idea at that which file system is running inside it. Like it's a UBFS, it's a CRAMFS. So whatever the our squash FS. Okay, generally devices uses squash FS a lot, CRAMFS a lot, many file system like you can see in this. Okay, and once you confirm that the firmware is not encrypted, it's a decrypted firmware. So if the firmware is encrypted, I once found a private key of the firmware inside the firmware only. I don't know how cool this because, but sometimes they do. And once I found a string to decode the firmware uh, inside the firmware only. So just run a hex dump -c, download see the data. Sometimes you may found the password, then decrypt the firmware, and then extract the firmware. Okay. And if the firmware is not encrypted at all, then just run binwalk -e. It will extract the firmware and it will give you a file. Now what? Now you have extracted the firmware. So now what? In how many of you have performed web application testing? Most of you, right? The biggest challenge is the content discovery in black box testing. But here in device security, you have all the document root with you. Sometimes it's encrypted embedded code inside the web application, or sometimes it's a plain document root. So uh, once you extract the firmware, you should definitely check for the passwd file to get the username password. Then you can check for the document root. What are the web application files available that you can attack from outer web? Then you can check the application binary, whatever the services is running on the device. You can get those binaries and perform reverse engineering, and you can exploit those binaries. Then you can take a look at the shell script. So what are the shell scripts are there? Then what it uh, what it is running, or is it generating a password runtime? Is it opening any service? Is it opening any backdoor using shell script? So many things can obtain from the shell script. Also, you can take also you can check for the .conf files inside the firmware to identify sensitive configurations. So here are the things which generally you can get from the firmware. So like what web server device is running, what passwords device have. Uh, Sometimes you may find a firmware inside the firmware. So like one firmware for device, another firmware is for the Wi-Fi of the device or Bluetooth of the device. Or if that device is communicating with other microcontrollers, then you can find that a firmware for that microcontroller inside the firmware of the device firmware. Okay, so you can find a multiple things. Also, you can find a ways to upgrade the device. So there was a one fight with one of the vendor which I was working. He said that this device cannot upgrade. This device only supports server upgrades. Only server can update the device. And I found that from this firmware, there is a way if you insert a USB drive inside that device reads that file and update the device. So I have demonstrated it. So you can find sometimes vendor may hide the stuff from you. You can find that stuff inside the firmware. And does device talk to any suspicious server? So basically, you can check for all the hard-coded IP addresses, URLs inside the firmware, and you can see if this device communicating with someone or not. and employee of the company. So developers generally write their full name, their email address, company stuff, developers comment. Well, like to fix this vulnerability, the below code is written. So you can see that code and um, check for the bypass of it. Okay. So many things you can obtain from the firmware analysis. Now you have performed the firmware analysis, you have performed the, now first you have set up the machine, then you perform a reconnaissance, you have all the data related with device, now you have all data from the firmware. Now what? Now dynamic testing. So first thing is we have to find out how this device will get communicated with your computer. As this device have a LAN port, so maybe we can set up a DHCP server and we can see if we can ping pong with that device or not. Okay, so let's take one router, connect your IP phone to that router, or if you remember, I said we need one extra LAN card. So you can connect that LAN card, connect that one port of LAN card to the device, other port of LAN card, and you have one LAN card with you also. So you can start a DHCP server. So one LAN card will become a client of the DHCP server on another LAN card. And you can connect one LAN card to the IP phone, means one interface to the IP phone. So this we can set up a DHCP server on local machine itself. Else, we can connect this device to the router and it will get an IP address and we can simply try to ping the IP phone. Now, first thing, we should do a Nmap. An Nmap flag, always remember you have to perform a full port scanning. Okay. So here is the Nmap result. Nmap-pn-p- aggressive and output is all format with IP phone dem. So what? So let's see what we get from here is like we found a telnet port is open. We found a 53 port. We found 80 web interface is open. We found 443 port. It is SSL and 7547. It is an unknown port. Oh, okay. Let's see. So from Nmap result, we found the telnet. I simply entered the IP address, telnet and IP address of the device. It asked for the username. I type admin with a blank password. I got a root. Here you can see. A root. So I don't think is there is any easy way to get a root of anything, right? Is there any way easiest way to obtain a root in just 5 seconds or 10 minutes? Like setting up device, running port scan, telnet to port, type admin, enter blank password, and you get a root. I think it's the easiest way, right? And what we found that device is running a web interface. Also, we found one port 7547 is open and 53 is filtered. So 7547 port generally used for PWMPC and 53 is used for a DNS mask. Okay, in embedded system. And also we found that Linux kernel is 2.6 and precisely 2.6.17 to 2.6.36. Let's see the kernel version here. Let me check here. Uh, okay. So there is in next slide we have maybe. We found the kernel version. Now you can simply go and check for the exploits available from 2.6.17 to 2.6.36. Now kernel version 5 is I think is in release now. 4 is for sure. So it's years old kernel you can find running on the device. Okay. Now setting up a burp suite. So most of the time burp gives the challenges in setup communication. But yes, it works. Like your IP phone will send a traffic to the burp suite and burp suite will send to the traffic here. Yeah, that's all. So like here you can see the request and here is the response. So like it is redirected to index.asp. Now, as I browse this page, index.asp, I found this login portal. And when I entered the login portal, I can see here a request response. So don't you think that it is vulnerable for clickjacking? I can't find the click X-frame option anywhere. So definitely this is vulnerable for the clickjacking, this device. Okay. Now point to be noted that we have one vulnerability that is missing clickjacking protection. Second, Oh, title says it all. So after browsing the device a lot, I found that there is one page called Go Form Set Sysadmin, where you can configure every parameter like admin user, admin type, then user type, then telnet security code, telnet local telnet enable, telnet port, telnet remote config, legal IP. It is 0.0.0. So that means any IP, right? Any IP can telnet like WAN IP, LAN IP, anything can communicate with the device. Okay, and in this one request itself you can do whatever you want, but don't you think here something is missing in the request? So like no, can you see any nonce? No, right? So this device, so we cannot, apart from cookie there is nothing on the device. Like apart from cookie there is nothing present inside the device. No csrf tokens are present, like no nonce is present. So if you just fire this request against any device, it will execute. Okay, so we have a request forgery now on device, we have a clickjacking, we have request forgery. Okay, after reversing the binary application binary, I found that this ping test is getting passed to the system call, and it is vulnerable, and it is executing whatever you send. So I just simply type id here and it gives me output of this. So now we have CSRF, now we have cross-site request forgery, and we have shell command injection. Now, chaining those vulnerabilities. First, how it works? Like generally, your office laptop is connected to your IP phone. Okay, so technically, your laptop is reachable to your office IP phone, right? So now chain these three vulnerability. Like you have make a one fancy page saying that we have updated the organization's policy. Click on I agree. Once you click on I agree, with the clickjacking, it will execute a CSRF and execute a command. That's all. With this, you can turn a simple IP phone into a botnet. So here you can see I have created one sample POC. When I click on I agree, it executes the ID command 10 times on the TMP/test POC. Isn't it critical? So that's all. This is how we can make our decent looking IP phone into a botnet. Okay. Now we got a code execution over device. So we have to test for the device internal security also. So once you got a shell, what you should check for? You should check for what are the packages are installed inside device, whatever the services are running on in the device, what are the versions of packages available inside the device, which may be vulnerable and which may found a other way to exploit a device. As we are a security researcher, we don't have to stop when we got a vulnerability. We have to find out all possible ways to exploit a device. So you can execute, you can find install software, you can check for the vulnerable software, core vulnerable software, you can get ls configuration, operating system configuration, and you can check for the operating system security, like what is the SE Linux status, what are the kernel module are loaded, is there any vulnerable cron job is running. So let's say you have a configured a cron, a cron job, and to execute one script like a procmon, it is monitoring the process and services is running or not, and you have given a 777, that is world writable. So what if if anyone got a lower privilege access on your device, he can modify that cron job, he can write his own script, and it will execute later when the cron job will run, and he can escalate the privileges from normal user to uh, root user, right? You can perform a permission abuse and privilege escalation using cron job. Now you have executed all this data and you have a dump at the device. So most of the time, I recently faced challenge with one device. Uh, Getting the data from device to the laptop is the second biggest challenge. So like you managed to get the root. Now what? Now you have to get this data. So what are the ways? You can perform a netcat communication to listener on device, and you can get this data. Second, you can sometimes you need to install a files on device for further testing. So how can you get it? You can test whether the wget is present inside device or not. You can wget the files. Then you can obviously you can install a busybox. You will get everything. Sometimes there are like in thinking this very high, sometimes we forget the basic way. So you should always ensure that device have any SD card. So like you can copy a data from device to SD card only, and you can fetch it. And you can also, if the device is running Android, you can get using ADB push pull and some proprietary commands. So like in this example, I have one FTP put and FTP get command through which you can get. So generally vendor customize their own ways to extract the data from the device. Okay. So this kind of internal testing you can perform in the device. Now, now you have perform a recognition. You have set up an arsenal, then perform a recognition, perform a firmware analysis, perform a sys internal testing, and lastly the heaviest section of this talk, that is fuzzing, reverse engineering, and exploit development. So sometimes we do need to fuzz the device to ensure that device is 100% secure. Like you found a way to hack a device, you found 2 ways, you found 3 ways, but also you have to ensure that there shouldn't be case where someone just run an exploit and get the shell over a device, right? To ensure that you have to fuzz each and every entry point of the device to ensure all device entry points are secure. So let's see how to do it. First thing is to get the shell. So like, how can you get the shell of device? By exploiting web vulnerabilities, by performing reverse engineering, by performing document review. Sometimes vendor have very specific way to obtain the shell over device. Then default credential, and lastly reverse engineering the binary. So in this case, I managed to reverse engineer the binary, and from that binary I got a SSH username and password. And once I got the SSH username and password, I logged into device and set up for the fuzzing. So due to time constraint, I'm not able to explain how to set up this device for fuzzing. So there is a YouTube video available on offensive embedded exploitation training. You can visit that for full details. So once you get a shell over the device, what you have to do is you have to perform you have to make your device fuzzing ready. For that, you have to enable a core dump, and you can set a pattern for core dump. Then you have to set a U limit to infinite, and then obviously you have to obtain something like this, a GDB server. So because you cannot either you can take those binary, run it on your system and debug it and fuzz it, or if it did that binary have dependency on the device, then you have to run it on device only. Then will you install a debugger on the device? Definitely not, right? So you can install a GDB server and attach that process and connect that GDB to our local GDB. Like you have to install a GDB multi-arc, and also you can use a PON GDB or uh, GDB PEDA for further analysis. Okay. Now you have set up a you have started a GDB server. No, you have you downloaded the GDB server. Now run the GDB. Now you first target the process which you want to hit. So here I have targeted a BOA root. So BOA is a web server for this, and that web server was responsible for handling all the HTTP and HTTPS traffic for the device. So I started this BOA web server and attached to the GDB server. And on PC side, I have started a GDB multi-arc. Maybe okay, it's already 100% zoom. Okay, so I have started a GDB multi-arc, and then here you can see I have connected somewhere. You can see GDB connect command. Okay, so target, remote, IP address, and the port. So here I have connected, and here you can see the status of the registers of the device. Okay. So once you set up a communication with a device, then you have to first. So generally, I prefer unauthenticated attack. Means I love unauthenticated attack because in pen testing field we know how much pain is to get authenticated. Uh, how much pain is there for getting authenticated. So here I targeted the login page, and I have targeted the login page, username admin, password admin. Okay, and then intercepted that request, send it to intruder, and intruder I have insert this this huge payload list. So basically it's a 2 times a, 5 times a, 10 times 20, 50, 100, 500, and up to millions and billions of a. And then I have decided to first all parameter here and started the attack. So you can see here. So here you can see no response from device. That means what might have happened? I'll tell you what happened. It crashes the web server. You can see here XOR read length in write body, read length 0, and our favorite kernel signal 6 or dumping code to flash time. Again, you might be wondering if the server is crashed, then why device is responding? You can see here the server got started again because there are some processes which periodically monitor whether the device service is up or not using cron job or using any other tool. Also, you can target those attacking for privilege escalation. Again, the server got up. Again, we fired our payload. Again, device gets crashed. So this keep happening. So then we can collect, we can transfer those crash files to the system. Now let's stick to this Stack Overflow here. This Stack Overflow. Okay. Here we got a 6 serve. Now what? Obviously, MSF payload, MSF pattern create and generate a length of. Here we have to identify which crashed the request. So here I can see a 5008. Here you can see this request crashes the device to 5008 at this field. In password field, when you fire a 5008, it creates a check fault. Now you create a payload with 5000 length 5000 and reproduce the crash. So here we have connected to device, we get the register values, we fired the crash, and once the crash is fired, we got a expected result. We got all the offsets here. So you can see we have started a web server, then we attach that web server with our GDB server, then we reproduce the crash here. Okay, this law for 414141. We come to know that register T4, T7, and from register S0 to S3 and return address. These all in our control. Okay, once you got the crash, once you matches the offset, now the second thing is you have to identify at what offset it got crashed. Okay, so from this offset value I have okay, so again we fired that request which is having a MSF payload, not MSF pattern create that string. We perform a crash and we got these values from register. Now match the offset. So MSF pattern offset query. So here we can see after after 1040 bytes, we have a controlled area. Then form 32, okay, form 28. So after 1027 byte, we have a write access, exact match as 28, then 28, then 32, 36, 40. So this looks like a register S0 to S6, S4, and return address at 1000. This is T4 and T0 register. So basically, we have to identify the register write access and all set. This is sufficient for any attacker to create a exploit. So I found this device here. I wrote an exploit and write these values here. So basically, this is T4 T4, T7 T7. This is S0 S0, S1 S1, S2 S2, S3, and the return address that we can control. So I wrote all the direct values to the register of the device. So what an attacker needs, shell code, maybe for a bind shell or reverse shell, and the padding, and boom boom, you own the device. Here is the exploit code. Here you can see it was a post request, and in that post request, I have added a payload for password field. A for 99 times, then padding till register T4, T4, and so on. So this is how, with one click or with just IP address, you can own the device. Isn't it a super critical than previous one? Thank you. I'm answering this question on Discord already. This is credit for all memes. Thank you, everyone. Hope you like this talk. You can follow me at Twitter at SecurityBeast, or you can mail me for any queries at kingkaustubh@me.com. Thank you again.